All right, we've been using logarithms for a hot minute now, so let's solve a logarithmic equation. Properties of logarithms, so I'm going to start by putting this into the exponent. I get natural log of x squared. And then I've got an addition of two logarithms, which means I can multiply their arguments together. So x plus. Now the reason why we do that is, like exponential equations, we have the same logarithm on both sides. With exponential, we could cancel out the bases. We can cancel out the logarithms. We'll go ahead and subtract x squared from both sides. So 5 minus root 37 over 2 would be a negative number. So if we're plugging that in, we can see we'd get a negative number here. If you're not okay with complex number outputs, then we exclude that solution. Otherwise, this is our final answer. All right, let's go ahead and solve this one by adding natural log of x minus 3 to both sides. Now notice both of their arguments are natural log of x minus 3. We can multiply these together using the addition property, but that's going to get complicated pretty quickly. So I'm actually just going to leave it as 2 natural log x minus 3 equals 5. This is going to be much more handy because I'll get to divide the 2 out as a constant, and I get natural log x minus 3 is equal to 5 halves. Now we can take the e of both sides, cancel that out. We get x minus 3 equals e to the 5 over 2. And then we add 3 to both sides, giving us e to the 5 halves plus 3. And that e is a positive number to any power, and then 3 is positive. So we get a positive solution. Similar to the last video, I'm going to go ahead and start by adding log x minus 1 to both sides. Now this time, I am going to multiply the arguments together. Because we're in base 10 now instead of base e, we won't create the same mess we would have if it was base e. So this would be log x squared minus 17x plus 16, and you go ahead and check that, equals 2. Now when we take it as a power of 10 to cancel out the logarithm, we get 10 squared is 100. And if we subtract 100 from 16, we get minus 84 equals 0. Now we can go ahead and factor this one. That would be, that would give us solutions of x equals 21 and x equals negative. Okay, so for this one, I'm going to start by multiplying both sides by the natural log of x minus 1, effectively putting that here. The reason why I'm going to do that is it gives me a constant with the 2, and I can move that to the exponent. Therefore, I can expand and distribute. So I'll ultimately end up, after all that, with natural log of x plus 1 equals natural log of x squared minus 2x plus 1, and that allows us to drop the natural logs and just deal with a polynomial equation. Okay, so we cancel out the 1s, and we'll cancel out one of the x's, so we get 0 is equal to x squared minus 3x, and we can ultimately just factor this. Now, again, if we plug in 0 to the denominator, we will end up with natural log of negative 1. If you're okay with complex number outputs, you're good. Otherwise, reject it, and we're done. Okay, so on both sides of this equation, we have a plus sign that we can use to multiply the arguments together. That would effectively turn this 2 into a constant that can be distributed to the 3x and minus 1. So that'd be log of 6x minus 2. And we do the same with the 4. We got 4x plus 8, giving us. This means we can go ahead and cancel out the logs, and we're just left with a linear equation to solve. 4x plus 8, and we add 2. Will this create any problems? No, because 3 times 5 minus 1 is 14, and 5 plus 2 is 7. Positive numbers there, so we're good. Okay, in this one, we have a subtraction sign, which means we need to use our difference property. That'd be the natural log of x plus 9 divided by x equals 1. Next, we'll take the e of both sides. We'll just be left with x plus 9 over x equals e. So let's go ahead and multiply both sides by x equals e times x instead of e to the x. We'll subtract x from both sides. We get e times x minus x on the right-hand side. Factor out the x. We get x times e minus 1, and e minus 1 is just a constant. And we get 9 over e minus 1 as our solution. Double checking it, e is greater than 1, so the denominator is positive, which means the whole thing is positive.